Machine learning in molecular design is a very hot topic. Welcome, listeners, to today's episode of Machine Learning in Molecular Design. I'm Sukant Khurana, Dr. Sukant Khurana. I'm joined by Bikram, a brilliant young researcher in computational biology. Bikram, it's great to have you here.
Thanks, Dr. Sukant. Super excited to talk about this topic.
Let's dive in. Molecular design, crafting new compounds for drugs, has always been a complex puzzle. Traditionally, it's been slow, iterative chemistry. How is machine learning shaking things up?
I will say it's totally revolutionizing the field. Machine learning lets you design molecules faster and smarter than ever. Instead of trial and error synthesis, we use models like variational autoencoders or GANs, generative adversarial networks, to propose novel compounds. I came across a project recently where they used the GAN to design small molecules for a kinase inhibitor. They cut the design cycle by half compared to standard methods. That's a massive leap.
Halving the cycle is no small feat, but with so many possible molecules out there, how does machine learning narrow down the choices effectively?
That's a great question, I will say. It's all about navigating the chemical space, which is like astronomically huge. I will say 10 raised to the power 60 possible drug like molecules. ML model, especially deep learning ones, learn patterns from databases like Zinc or PubChem. They score compounds based on properties, binding affinity, solubility, toxicity.
Prioritizing synthesizability is key. What about data challenges? You need good training sets for these models, don't you?
Oh, absolutely. Data is the backbone. You are pulling from curated database or proprietary libraries, but the catch is quality here. Public databases can have errors, wrong stereochemistry, incomplete annotation.
Smart strategy. One thing I've wondered, how do you ensure these ML generated molecules aren't just theoretically nice, but practically viable?
That's the $1 million question, actually. So, viability, where interpretability comes in. Black box model can churn out weird structure if you are not careful. I'm really into tools like attention mechanism in transformers. They highlight which molecular fragments drive a prediction, like a lipophilic group boosting binding.
Combining approaches sounds powerful, must be computationally demanding though.
Yeah, it can tax your GPUs, but cloud computing is actually making it doable. Plus, algorithms are getting leaner every year.
Fascinating. Where's ML making big difference? Maybe in which area of molecular design?
I'd say biologics design, like antibodies or peptides. Small molecules get all the hype, but ML is cracking open larger molecules. I saw a study where a reinforcement learning model optimized an antibody's CDR region for better affinity to a cancer antigen. It analyzed thousands of sequences in hours, something manual design couldn't touch. So that is opening doors for personalized meds.
That's exciting for precision medicine. What's the next frontier you see in this space?
I'm well pumped about closed loop systems. Imagine ML designing a molecule, a robotic lab synthesizing it, and the results feeding back to retrain the model, all automated. So we are seeing early versions with active learning. It's like the system teaches itself to get better. Plus, federating learning is letting labs collaborate without sharing proprietary data, which is used for scaling up.
Well, that's bold vision. One concern though, does the field ever risk over relying on ML and skipping chemistry fundamentals?
So that is definitely a risk. I have seen teams get dazzled by shiny ML outputs and forget to validate. So machine learning is not a crystal ball, it's a tool. The best setups are iterative, design with ML, test in the lab, refine the model.
A good reminder to stay grounded. Final thoughts on where ML in molecular design is headed.
It's rewriting how we innovate, uh, faster designs, bolder ideas. I'm just thrilled to be part of it, pushing for compounds that could save a life.
Inspiring words, Vikram. Thanks for sharing your insights and thank you, listeners, for joining us. Until next time.